Today we're going to take a look at Pythagorean inequality theorem. What we're going to do is we're going to use Pythagorean's theorem to see if a triangle is a right triangle, and we're also going to go further than that, and we're going to determine if a triangle is obtuse or acute. So let's just jump right into these. We've got a few notes that we can have here you might want to write down. The first thing we're going to notice is that our triangles, we've talked about this particular thought numerous times, but remember when we're determining if three sides can be a triangle, if we have this, the small side plus the medium side has got to be greater than the larger side. So when we add up those two smaller sides, we need to make sure that they are greater than the largest side. So we've got a list of a few here, and we're going to see what we have. Now, they don't have to be listed in order. Remember, it's the two smaller sides. So 3 plus 6 is 9, which is greater than 8. So this is, and again, we're not determining that it's a right triangle here. We're just determining that it is a triangle, period. Because if it's not even a triangle, there's no reason to determine if it's a right triangle. So in this one, the two smaller sides are 5 and 7, which makes 12, and 12 is greater than 9. Therefore, this is a triangle. Third example, we have 10 and 3, which is 13, and 13 is not greater than 14, so this one is not a triangle. This one's not a triangle. On the next one, we have 22 plus 19, that is 41. Well, 41 is equal to 41, but it needs to be greater. So this is also not a triangle. And then on the last one, we see 34 plus 42, that's 76. 76 is much greater than 60. So therefore, this one is a triangle. First two is a triangle as well. All right, check this when you first start going, because there's no need to even mess with Pythagorean's theorem if it's not even a triangle in itself. This little section here is basically the bulk of what we're going to be doing today. And what we need to know is we are going to determine if a triangle is an acute triangle, right triangle, or obtuse. Let's go ahead and start with the right triangle that we know. We know on Pythagorean's theorem, if a squared plus b squared is equal to c squared, we know that this is a right triangle. Now, moving further down, here's the way I like to look at these. It's a competition between the a squared and the b squared versus the versus the c squared. It's the little guys versus the big guys. Now, what we need to know is this, and then this is what you'll need to highlight for yourself. If the small guys, a squared plus b squared, are greater than the big guy, which is c squared, we have an acute triangle. The cute little guy is 1, right? So our competition, we have an acute triangle because the small guys became larger than the large guy. And if the a squared plus b squared are less than c squared, we have an obtuse. So if the big guy wins, it's obtuse. Big guy, big angle, small guy, small angle. So that means, again, that's on an acute triangle, all of the triangles are acute. On a right triangle, one angle is right, and on an obtuse triangle, one angle is obtuse. You can't have more than one right or obtuse triangle. Now this says, what the sides of a triangle are 3, 4, 5. What kind of a triangle is this? First of all, I hope at this point we recognize that a 3, 4, 5 triangle is a right triangle. And any factor of that, 3 times 2, 4 times 2, 5 times 2, the 6, 8, 10 is a triangle. If I do 3 times 3, 4 times 3, 5 times 3, these are all what's called a Pythagorean's triple. There are more than just 3, 4, 5, but 3, 4, 5 is one that always works as well. We're going to show it working real fast, but from here on out, what you need to know is that a 3, 4, 5 triangle is always a right triangle. And as we do this, you can see that this does equal, and the result when the two are equal is the right triangle. But on a 3, 4, 5 triangle, I hope that we recognize that this is always a right triangle, or any factor therein. So as I look at this one, I can determine that this is not a right triangle just because I know the 3, 4, 5 multiples. And this is 4 and this is 5 times 2. And this is definitely not 3 times 2. So that side's a little smaller than it should be. So I know I don't have a right triangle here. But we're still going to set up Pythagorean's theorem the way that we know to, which is leg squared plus leg squared equals the hypotenuse squared. But I know good and well that this is not equal, but I'm just using that to hold my space there. So 4 squared is 16. 8 squared is 64. Add those together, you get 80. 10 squared is 100. So 80 is definitely not equal to 100. 80 is less than 100. So since the small guy's lost, our triangle is obtuse. This is an obtuse triangle. And we knew it was a triangle to start because 4 plus 8 is 12, and 12 is definitely... All right, this one, we definitely have a triangle because 6 plus 6 is 12, and 12 is greater than 7. This is an isosceles right triangle. So if we knew our isosceles right triangle, we would know that the hypotenuse would be 6 square root of 2, which is not 7. So we know that this is not a right triangle as well. But let's figure out what we do have. Again, same process, leg squared plus leg squared compared to the hypotenuse squared. Again, I'm just dropping an equal sign down here because I'm just as a space holder. So this is 36, this is 36, and this is 49. So 36 plus 36, we got a 72 measurement, which is clearly bigger than the hypotenuse squared. So the little guys won. When the little guys won, it's so cute when the little guys win, but it is an acute triangle. Here we go again, and if you're picking this up, guys, you go right ahead and get to work on your own. These two values are greater than 18, so we do know that this is a triangle. Now we're going to see if it is a right triangle. So leg squared plus leg squared equals the hypotenuse squared. So 64 is 8 squared. 16 is 256. And 18 squared is 324. So when I add these two values up here, I get 320 compared to 324. It's a close battle, but it doesn't matter. We have a winner. The large side won, therefore we have an obtuse triangle. All right, so let's take a look at this one. We have a triangle with sides of 43, 41, and 38. What kind of a triangle is it? First of all, it is a triangle because 38 and 41 are two smaller sides, are bigger than our largest side. Now, hopefully you didn't let me pull one over on you here. We've got our sides, the whole time we've been listing them in order from, ascending order from lowest to highest. But this time, they're a little out of order. But we still do the same thing. Leg squared plus leg squared compared to the hypotenuse squared. Now we need a calculator for all of these, of course, but 38 squared, I've already got this in my calculator, is 1444. 41 squared is 1681. And 43 squared is 1849. So when we add up our two terms on the left, we get 3125, which is considerably greater than 1849. So the little guy's won. We have an acute triangle. And the last one we'll take a look at today. A lot of people panic when they see the decimals and fractions, but you're not doing anything with these numbers. It's your calculator that it is, so don't complain. If your calculator wants to complain, it's welcome to do that. 6 plus 4.2 is 10.2, which is greater than 9.8. So we do, in fact, have a triangle here. So let's see if it's see what kind of a triangle it is. So we go 6 squared plus 4.2 squared, and we're going to compare that to 9.8. Again, I'm just using the equal sign for now to hold my place. So 6 squared is 36. 4.2 squared is 17.64. And 9.8 squared is 96.04. 36 plus 17.64 is 53.64, which is smaller than 96.04. So the big guy won. When the big guy wins, we have obtuse triangles. So there you have it, guys. And all the ones we did on the examples ended up being acute or obtuse, but remember, right is still an option. When we have a tie goes to the right angle, so we'll give it to the right angle. You guys have a Delta math to work on? Good luck.